Professor Avi Loeb doesn't make wild claims lightly. As the former chair of Harvard University's astronomy department, as the founding director of Harvard's Black Hole Initiative, as someone who has authored over 1,000 scientific papers and advised dozens of PhD students, his reputation is built on rigorous science and careful reasoning. So when he says that interstellar object 3I Atlas might not be a natural comet, when he suggests it could be an artificial probe sent by extraterrestrial intelligence, people listen, not because they necessarily agree, but because Avi Loeb has earned the right to ask uncomfortable questions. And the questions surrounding 3I Atlas are profoundly uncomfortable, because this isn't about vague speculation or wishful thinking. This is about 9 specific anomalies that Loeb has documented in scientific detail. 9 characteristics that don't match what we expect from natural comets. 9 pieces of evidence that, when taken together, paint a picture that challenges everything we thought we understood about interstellar visitors. Let me walk you through each anomaly, not with speculation, but with the actual observations that have astronomers around the world scratching their heads. Because whether 3I Atlas is a comet or something else entirely, the data we're collecting is extraordinary, and the implications are staggering. Anomaly number 1, the trajectory. When scientists calculated 3I Atlas's path through our solar system, they discovered something remarkable. This object's orbital plane aligns almost perfectly with the ecliptic, the flat disk where all our planets orbit. The inclination is just 5 degrees. Think about what that means. This object traveled through interstellar space for potentially billions of years, arriving from outside our solar system, and its path just happens to line up with the plane where all our planets exist. Loeb calculated the probability of this alignment occurring by chance. The result? Less than 1 in 100. Now, a 1% probability isn't impossible. Unlikely things happen, but it's the first data point in a pattern, because 3I Atlas doesn't just align with our planetary plane. Its trajectory brings it suspiciously close to multiple planets during its visit. Close to Jupiter, close to Venus, close to Mars, and in December, relatively close to Earth. If you were designing a reconnaissance mission to survey the major planets of an alien star system, this is exactly the trajectory you would choose. A single pass that brings you near multiple worlds, allowing comprehensive observation while conserving energy. Loeb stated explicitly that this trajectory pattern suggests a reconnaissance probe sent by alien beings. Strong words from a Harvard professor, but are they justified by the evidence? Anomaly number 2, the missing dust tail. When 3I Atlas emerged from behind the Sun on November 5, 2025, telescopes around the world turned to observe it. Scientists expected to see a massive dust tail streaming behind the object, because just days earlier, on October 30th, when 3I Atlas reached perihelion, its closest approach to the Sun, observations showed it had undergone non-gravitational acceleration. Something was pushing this object off its predicted path. The standard explanation for non-gravitational acceleration in comets is outgassing. Ice on the comet's surface heats up, turns to gas, and jets outward, creating thrust that alters the trajectory. But here's the problem. When approximately 13% of a 33 billion ton object vaporizes, when that much material explodes into space in a matter of days, it should create a visible tail, a massive plume of gas and dust that stretches for millions of kilometers, clearly visible in telescopic images. Avi Loeb calculated exactly how much material should have been lost, roughly 5 billion tons. That's not a subtle amount. That's a catastrophic outburst that should produce spectacular visual effects. Astronomer R. Naves at his observatory in Spain captured images of 3I Atlas on November 5th. The photographs showed a compact source of light, no extended coma, no dust tail streaming away from the Sun, nothing that looked like a typical comet experiencing massive outgassing. Loeb noted in his analysis, for a typical comet experiencing the expected amount of outgassing, the evaporated material should have resulted in a coma with gas that would have been pushed by the radiation pressure and solar wind into the shape of a typical comet tail pointing away from the Sun. But that tail doesn't exist, or if it does, it's far smaller than physics predicts it should be, which raises an obvious question. If massive outgassing didn't create the non-gravitational acceleration, what did? What force pushed 3I Atlas off its predicted trajectory? Anomaly number 3, the anti-tail. Before 3I Atlas disappeared behind the Sun during its perihelion passage, observers documented something bizarre. The object displayed what astronomers call an anti-tail, a stream of material pointing toward the Sun instead of away from it. This is physically unusual. Comet tails point away from the Sun because solar radiation pressure and solar wind push gas and dust outward. A tail pointing toward the Sun defies the expected physics. NASA attempted to explain this anti-tail as an optical illusion, a perspective effect where particles in the comet's orbital plane appear to point sunward when viewed from certain angles. It's a known phenomenon called a dust fan or sunward spike that can occur with comets that have flat, disk-like debris fields. But Loeb remained skeptical of this explanation. He requested the highest resolution image available, the photograph taken by the high-rise camera aboard the Mars Reconnaissance Orbiter on October 2nd, when 3I Atlas passed within 30 million kilometers of Mars. That image has never been publicly released. Loeb reached out directly to the principal investigator of the high-rise camera, writing, "Can I get the image? I am a scientist." He received no response. During his appearance on the Joe Rogan Experience, he discussed this refusal with frustration, suggesting that the image might contradict NASA's explanation of the anti-tail as a normal dust fan. Why would the clearest, highest resolution image of 3I Atlas be withheld if it simply confirmed what NASA was already claiming? Anomaly number 4, the color. 3I Atlas exhibits an unusual blue coloration, particularly during its approach to the Sun. This blue appearance could indicate several things. One possibility is ionized carbon monoxide, which glows blue when heated. Another possibility, and this is where Loeb gets provocative, is thermal emission from a heated engine. He stated to the Daily Mail, the non-gravitational acceleration could stem from cometary evaporation or technological propulsion. Technological propulsion, from a Harvard professor. Those words carry weight, because Loeb isn't saying, "I believe 3I Atlas is a spaceship." He's saying, the observations we have are consistent with multiple explanations, and we should investigate all of them, including the possibility of artificial technology. That's not pseudoscience. That's exactly how science is supposed to work. You consider all hypotheses that fit the data, then design observations to distinguish between them. Anomaly number 5, the nickel emission. Spectroscopic analysis of 3I Atlas revealed something extraordinary. The object is emitting approximately 4 grams of nickel per second. But here's what makes this strange. There's no corresponding iron emission. In natural rocky materials, particularly in materials formed in stellar environments, iron and nickel occur together. They're chemically similar, they form together in supernovae, they're incorporated together into asteroids and comets during planetary system formation. Finding nickel without iron suggests either a formation environment radically different from anything we understand, or a composition that isn't entirely natural. Could there be natural processes that separate nickel from iron in cometary nuclei? Possibly, but we don't know what those processes would be. This is anomalous chemistry that requires explanation. Anomaly number 6, the extreme negative polarization. In September 2025, observations from the Very Large Telescope, Nordic Optical Telescope, and Roshan Observatory revealed that light reflected from 3I Atlas's coma exhibits extreme negative polarization. This means the light's oscillations are oriented along the Sun-Comet observer plane to an unusually high degree. A paper published on this finding noted the combination of low inversion angle and extreme negative polarization is unprecedented among comets and asteroids, marking 3I Atlas the first object known with such polarimetric behavior and representing a previously unobserved population. Unprecedented. First object known with such behavior. These aren't words scientists use lightly. 3I Atlas isn't just unusual, it's displaying optical properties we've never seen before in any comet or asteroid. The polarization pattern is similar to what's observed in trans-Neptunian objects, suggesting its surface or coma is made of a mixture of icy and dark material. But the degree of polarization exceeds anything previously measured. Why? What about 3I Atlas's composition creates this extreme optical signature? Anomaly number 7, the hyperbolic trajectory. 3I Atlas is moving through our solar system with an orbital eccentricity of 6.137. For context, elliptical orbits, like the orbits of planets and most comets, have eccentricities less than 1. Parabolic trajectories, the boundary between bound and unbound orbits, have an eccentricity of exactly 1. Hyperbolic trajectories, the paths of objects passing through our system from interstellar space, have eccentricities greater than 1. But 6.137, that's extremely hyperbolic. That means 3I Atlas is moving at over 130,000 miles per hour relative to our solar system, approximately 209,000 kilometers per hour. This is not an object that originated here. This is not something that was gravitationally scattered from the Oort cloud or the Kuiper belt. This object came from outside, from the darkness between stars, and it's just passing through. Anomaly number 8. The age. Based on its trajectory and speed, astronomers estimate 3I Atlas could be approximately 7.5 billion years old. That would make it roughly 3 billion years older than our entire solar system. This object existed before our sun formed, before Earth formed, before any planet in our solar system came into being. It has been traveling through the galaxy since a time when the Milky Way looked completely different than it does today. What has this object experienced during those billions of years? What star systems has it passed near? What cosmic environments has it survived? The surface of 3I Atlas, according to James Webb Space Telescope observations, has been transformed by billions of years of cosmic ray bombardment, creating a deep irradiated crust that penetrates 15 to 20 meters into the nucleus. This isn't pristine material from its formation environment. This is matter that has been fundamentally altered by eons of exposure to the harsh radiation environment of interstellar space. But beneath that crust, what remains? Is there material inside 3I Atlas that still retains information about its origin, about the stellar system where it formed, about conditions in the galaxy 7.5 billion years ago? Or, if Loeb's hypothesis is correct, beneath that radiation-damaged surface, could there be something else entirely? Anomaly number 9. The direction of arrival. This might be the most provocative anomaly of all. When astronomers traced 3I Atlas's trajectory backward through space, calculating where it came from before entering our solar system, they discovered something extraordinary. The object arrived from a direction that aligns within 9 degrees with the source of the famous WOW signal detected by Ohio State University's Big Ear radio telescope in 1977. The WOW signal remains one of the most intriguing unexplained phenomena in the search for extraterrestrial intelligence. On August 15, 1977, the Big Ear telescope detected a 72-second radio signal from the constellation Sagittarius. The signal was so strong, so clearly artificial in its narrow-band characteristics, that astronomer Jerry Eman circled it on the computer printout and wrote "WOW" in the margin. Despite decades of follow-up observations, that signal has never been detected again. Nobody knows what produced it. Natural astronomical sources don't create signals with those characteristics, but we've never found the source. Now, 48 years later, an interstellar object arrives from almost exactly that same direction. Loeb calculated the probability of this alignment occurring by chance, 0.6%, less than 1 in 150. Combined with all the other anomalies, this directional coincidence becomes harder to dismiss as random chance. But here's where Loeb adds his 10th anomaly, one that brings all the others into sharp focus. He notes that 3I Atlas contains only 4% water by mass. For comparison, typical comets are substantially water ice. Comet Borisov, the second confirmed interstellar visitor, showed normal water content for a comet, but 3I Atlas, only 4%. This is not a typical icy comet. This is something with a radically different composition. And the nickel to cyanide ratio, orders of magnitude larger than any known comet, including Borisov. The probability of this occurring naturally, according to Loeb's analysis, is less than 1%. Nickel in the proportions observed in 3I Atlas resembles industrially produced nickel alloys, the kind of nickel you'd find in spacecraft components, not in natural cometary material. Loeb emphasizes repeatedly that he's not claiming 3I Atlas is definitely artificial. He's arguing that the technological possibility is significant enough to merit serious scientific investigation. And he's right. because if even one of these 10 anomalies suggested artificial origin, we could dismiss it as coincidence. But 10 anomalies? 10 characteristics that don't match natural comets. 10 pieces of evidence that, individually unlikely, collectively paint a coherent picture of something extraordinary. The scientific method demands that we consider all hypotheses consistent with the data. Natural comet with unusual properties? Possible. But we need to explain why it has 10 different unusual properties, each with individual probabilities below 1 or 2%. Technological artifact? Also possible. And if we're being honest, it would explain all 10 anomalies simultaneously with a single hypothesis. Loeb pointed out something crucial during his interview on News Nation's Banfield program. He said, "There was some propulsion that moved it away from its original trajectory, and I would have expected it would lose 10 to 20% of its mass as a result of the recoil. But the observations don't show that mass loss. The dust tail that should exist isn't there. The outgassing that should be visible isn't visible. So what created the non-gravitational acceleration? One possibility, the one that keeps astronomers awake at night, is that 3I Atlas has some form of propulsion system, not chemical rockets, not anything we would recognize as conventional spacecraft technology, but some method of generating thrust that doesn't rely on ejecting material." Loeb mentioned in his blog that the blue coloration could come from a source of artificial light or represent thermal emission from a heated engine. These aren't statements he makes lightly. Loeb has faced significant criticism for his willingness to consider artificial origins for interstellar objects. After he suggested Oumuamua might be a light sail or probe, colleagues accused him of sensationalism, of damaging the scientific credibility of SETI research. But Loeb stands by his approach. He argues that being afraid to investigate uncomfortable possibilities is bad science. That if we're searching for extraterrestrial intelligence, we need to be willing to recognize it when evidence appears. And with 3I Atlas, the evidence is mounting. Not proof, but evidence. A pattern of anomalies that doesn't easily fit natural explanations. Loeb wrote on Medium, "My hope is that data collected in the coming weeks, especially around December 19th, 2025, when 3I Atlas gets closest to Earth, will reveal the true nature of this interstellar object." December 19th. That date looms large, because on that day, 3I Atlas will pass within 167 million miles of Earth, approximately 269 million kilometers, or 1.8 astronomical units. In cosmic terms, that's close enough for our most powerful telescopes to observe it in unprecedented detail, close enough to potentially resolve some of the mysteries that have accumulated since its discovery. The International Asteroid Warning Network has organized a coordinated observation campaign running from late November through late January. Telescopes around the world will track 3I Atlas continuously during this period. Radio telescopes will listen for any emissions. Infrared telescopes will measure thermal signatures. Optical telescopes will photograph its coma and search for any tail material. Spectroscopes will analyze its chemical composition in exhaustive detail. This campaign represents humanity's best chance to understand what 3I Atlas truly is. If it's a natural comet with unusual properties, the observations should eventually reveal processes that explain the anomalies. Maybe its formation environment was so different from our solar system that it created chemical signatures we've never seen before. Maybe the billions of years of cosmic ray exposure altered its surface in ways that produced the unusual polarization and missing tail. Maybe there are physical processes occurring in interstellar space that we don't yet understand. But what if the observations don't reveal natural explanations? What if the data from December and January shows even more anomalies? What if high-resolution images reveal structure that can't be explained by natural formation? What then? Loeb has been explicit about what should happen next. He believes NASA should release all available data about 3I Atlas to the global scientific community. The Mars Reconnaissance Orbiter image from October 2nd, the Swift telescope observations, the SOHO and stereo coronagraph data. Everything. Because this isn't just NASA's discovery. This is potentially the most important astronomical object humanity has ever observed. If there's even a small chance that 3I Atlas represents technology from another civilization, that information belongs to everyone. The reluctance to release certain images troubles Loeb deeply. He mentioned during the Joe Rogan podcast that he found it suspicious NASA won't share the high-rise photograph, the clearest image available of the object. He used a vivid metaphor. It's like a pet showing up at someone's home while their family insists it's just a street cat, despite the fact that it has an unusual tail growing from its forehead. If 3I Atlas is just an unusual comet, why not release the image and let scientists analyze it? There's a deeper issue here about how we approach the search for extraterrestrial intelligence. For decades, SETI has focused on radio signals. We've built massive telescope arrays, listened to millions of stars, searched for narrowband transmissions that would indicate technological origin, and we've found nothing. Or more precisely, we found one unexplained signal, the WOW signal that we couldn't repeat. But what if advanced civilizations don't broadcast radio signals? What if they communicate through methods we haven't discovered yet? What if their technology is so advanced that it looks like natural phenomena to us? How would we recognize an alien probe if it appeared in our solar system? Loeb argues that we need to expand our thinking. Instead of just listening for signals, we should be examining unusual objects that enter our system from interstellar space. We should be looking for anomalies, for characteristics that don't fit natural explanations. And when we find those anomalies, we should investigate them thoroughly, not dismiss them because the implications make us uncomfortable. The Galileo project, which Loeb founded and directs, is specifically designed to search for physical evidence of extraterrestrial technology, not just radio signals, but actual artifacts, probes, satellites, light sails, anything that might represent technology sent by another civilization. The project has installed telescope systems that continuously monitor the sky for unusual aerial phenomena. And it treats interstellar objects like 3I Atlas as high-priority targets for investigation. Because here's the reality that Loeb keeps emphasizing. We live in a galaxy with hundreds of billions of stars. Most of those stars have planets. Many of those planets are inhabitable zones where liquid water could exist. The chemistry of life is universal. Carbon, hydrogen, oxygen, nitrogen, these elements exist everywhere. If life arose on Earth, it almost certainly arose elsewhere too. And if life arose elsewhere, some fraction of it probably developed intelligence and technology. The Milky Way is approximately 13 billion years old. Our solar system is only 4.6 billion years old. That means there were 8.5 billion years for other civilizations to arise before us. If even one civilization achieved interstellar travel capability during that time, if they sent probes to explore the galaxy, those probes could be everywhere by now. Traveling at even a fraction of light speed, you could explore the entire galaxy in a few million years, which is nothing on cosmic timescales. So the question isn't, could there be alien probes in our solar system? The question is, why wouldn't there be? If we're planning to send interstellar probes to nearby star systems, why wouldn't other civilizations do the same? And if they did, what would those probes look like after billions of years of travel? Maybe they'd look like comets. Maybe they'd coat themselves in ice for radiation protection during the long journey through interstellar space. Maybe they'd enter star systems along orbital planes that allow close approaches to multiple planets. Maybe they'd use close solar passes to power systems that have been dormant for millennia. Maybe they'd exhibit characteristics that astronomers would initially interpret as natural, only revealing their artificial nature through careful analysis of accumulated anomalies. This is the possibility that Loeb is asking us to consider. Not 3I Atlas is definitely an alien probe, but 3I Atlas exhibits characteristics consistent with artificial origin, and we should investigate that possibility seriously. It's a reasonable position. It's scientific. It's exactly what we should be doing when faced with unexplained phenomena. The criticism that Loeb has faced for this position reveals something troubling about modern science. There's a tendency to reject ideas that seem too extraordinary, even when those ideas are consistent with available evidence. Carl Sagan famously said, "Extraordinary claims require extraordinary evidence." But Sagan also said, somewhere, something incredible is waiting to be known. He understood that you can't make discoveries if you're not willing to look. Loeb isn't claiming to have proof. He's claiming to have evidence worthy of investigation. 10 anomalies, each unlikely on its own, collectively suggesting something we've never encountered before. And he's calling for the data needed to investigate properly. That's not sensationalism. That's how science advances. In a few weeks, we'll have more data, high-resolution images from December 19th's close approach, detailed spectroscopy, precise measurements of the object's size, rotation, and surface features. That data will either support natural explanations for the anomalies, or it will deepen the mystery. Either outcome is valuable. Either way, we learned something profound about what exists in our galaxy. But there's urgency to this investigation because 3i Atlas is leaving. After December, it will begin its journey back out of the solar system, accelerating as it moves away from the sun, eventually disappearing into the darkness of interstellar space. We'll never see it again. This is our only chance to understand what it is, our only opportunity to collect data that might answer questions that have haunted humanity since we first looked up at the stars. Are we alone? Have we been visited? Is there technology out there, sent by civilizations long dead, still functioning after billions of years, still carrying out missions programmed by beings we'll never meet? 3i Atlas might hold answers, or it might just be an unusual comet, but we won't know unless we look. Really look, with open minds and careful analysis, and all the technological capabilities we've developed precisely for moments like this. December 19th, 2025. Mark that date, because on that day, humanity will get its closest look yet at an object from another star system, an object that has traveled billions of years and crossed unimaginable distances to pass through our small corner of the galaxy, an object that might be exactly what it appears to be, or might be something far more extraordinary. Avi Loeb is watching, telescopes around the world are watching, and now you're watching too, because whatever 3i Atlas turns out to be, the answer matters. It matters for science, for our understanding of the universe, and for our place in it. We live in a time when we can finally begin to answer the oldest question: are we alone? 3. Atlas might not provide the definitive answer, but it's moving us closer, one anomaly at a time.